As we continue with section 3 of chapter 3, this section is on intercepts. And here is a screen view of a TI-84 graphing calculator, and it's showing us some intercepts. For instance, right here, there is a y-intercept, and right here, there's another. And then here, there's an x-intercept. So they're asking us to list these points. We can start with this one. Looks like a -3, 0. And remember, the x-intercept is written in the form a, 0. And we'll do the y-intercept right here. This one is going to be a 0, 2. And y-intercepts are written in the form of 0, b. Remember that letter B, that's your y-intercept. And A is your x-intercept. And this one will be 0, -2. All right, going up. Listing the intercepts. So over here, it looks like about halfway. So that's a -1.5, 0. I guess I put that in the wrong place. It's supposed to just be a comma. Then this looks definitely like a 0.3. This one's hard to tell, but the book said it was this. And then here, this was a little hard to tell too. Again, thick lines make it hard to read carefully. And if you don't have a line though, you can't see it. So they're saying this is 0.6 for the y-intercept over there. And there's your x-intercept. Okay. Now we had already introduced the idea of the special t-chart that gave you your x and y-intercept. So we had done this already, so a nice little review. 1, 2, 3, 4. And then 1, 2, 3, 4. And then with your line. And like so. So here they're asking us to make another t-chart, so to speak. And I'm saying you only need to do this much. They'd like you to do another point, just for sure, but again, if x is 0, if x is 0, y is going to be -1. If y is 0, this is going to be a -1/4. All right, here's a case where a -1/4 might be hard to plot. So in a case like that, what I would suggest is that you convert it to Slope-Intercept Form, where you solve for y by transposing the 4x becomes a -4x. Your -1 stays as your y-intercept. And now you have -4 over 1. So you're going to go over 1 and then up 4. And then you can get a nice straight line, because that 1/4 right there, a -1/4, very hard to plot. Now, for something like this, this is not in standard form, so I would recommend that you solve it for Well, put it in standard form. Bring the x over. So as I was saying, bringing the x over to the other side makes it a negative x. Now it's in standard form and easy to use this t-chart. So if x is 0, y will be a negative 2. And if y is 0, a negative x equals a negative 6, but a positive x equals a positive 6. Just change the signs. So now you have your 2 dots. So right there, 0, negative 2, and then 6. 1, 2, 3, 4, 5, 6. And your line. Okay, going on to these next two. As you can see, it's in standard form. So if x is 0, dividing both sides by a negative 2, we get y is a negative 3. If y is 0, a negative x equals 6, so a positive x equals a negative 6. And again, this is your y-intercept, this is your x-intercept. I plotted the points, now it's just a matter of making the line. Now remember, how many points are along this line, as we mentioned? Well, there's an infinite number of points. But what we've done here is we've looked at the x-intercept there and the y-intercept, where it will cross the x and y axis. Here this is in standard form, but when x is a 0, y is 10 over 4. That reduces to 5 over 2. That in decimal form is 2.5. And then if y is a 0, x is 5. So I plotted these points, and it's just being able to plot that point in the middle. And that's what it looks like. Again, there's your y-intercept, there's your x-intercept. And we're using that special t-chart. Now, items 9 and 10 are a little tricky because notice there is no y here. So what we want to do is solve for a positive x. Bring the x over to this side, it becomes positive. Bring the negative 3 over to this side, and we have this. So this is that special formula that we're calling Formula 6, ax equals a, which is a vertical line through a. In this case, it's 5. So 1, 2, 3, 4, 5. We're going to do a vertical line through 5. And there's our equation. Now this next one, again, there is no x, there's just y. So I'm going to bring the y over to this side, make it positive, and then bring my positive 2 over to this side. It becomes negative, so a negative 6. This is a special formula for a horizontal line. Y equals negative 6. Negative 6 is our b. So 1, 2, 3, 4, 5, 6. And I then take my line. And that one's not too good. Let's try another one here. There's one better. And there's our equation. Now notice, this is another one down here for number 11. But here we have to solve for x. So transpose the positive 6, makes it a negative 12, divide by 3, x equals negative 4, a vertical line through negative 4. Here we transpose the positive 8, it becomes a negative 8, plus 12 is 4, divide by 2, Here we get y equals 2. Horizontal line at 2. I see we are at 10 minutes, so we're moving on. Now, in looking at these two equations, they want us to plot it on the same graph. Well, notice, what's our slope here? Well, a negative 1 over 1. But our y-intercept, there isn't any, so the y-intercept is 0. Here, this is the same, a negative 1 over 1, and then our y-intercept is a negative 4. So let's do that. So our first point will be here, and it's negative, so we're going to go over 1, up 1, and we can put a couple of points there. Okay, so that's this graph. And now this one is going to be the very same, except we go down to our y-intercept, which is now 4, over 1, up 1, over 1, up 1. So these are our lines. Ooh, I hit the wrong button. So in graphing these, notice they both were y equals a negative 1, 1x, and this had a plus 0, and this was y equals a negative 1x minus 4. So there our y-intercept was 0, and then over 1, up 1. And here our y-intercept was a negative 4 right here. And since the slopes were the same, the lines were parallel. All right, here we had to solve for x. We then get x equals negative 2, and here, solving for x, x equals 3. Again, since they're only the x term, that's that special form of x equals a. We're calling that Formula 6 from our lesson, and these are the lines. These would be also parallel. So in this one, again, they're both y equals b equations. And when I solve it for positive y, y equals 3, that's this line. And then here, solving it for a positive y, y equals negative 3. All of these equations are parallel. Okay, let's look at number 16. Two lines in the same plane that do not intercept are called parallel lines. Graph the lines x equals negative 2. Graph the parallel line at 3. Okay, so here's our first line, x equals negative 2, and a line that would be parallel that intersects at 3 would be this one. What is the equation of this line? Well, it's going to be x equals 3. It's getting to be a little easier, I think, now that we're getting, a lot of drill. Okay, in this one, as you read it, it's giving you this formula that I put in this form, and you say, hey, this is standard form. And what they're asking are for the x and y intercepts. So there's our y-intercept, there's our x-intercept, and then when we graph it, there's, instead of being 5, this is now 50, and this is 80, and there's our graph. Wow. So, for number 25 here, if 25 chests are manufactured, find the greatest number of beds that can be made. Well, it takes 5 hours to make a bed, 8 hours to make a chest. So we put the 25 chests by the y. That gives us 200. We subtract 200 from both sides. We then divide both sides by 5, and we get then 40 beds. Okay, we've kept this around 15 minutes. Lots of stuff. Again, you can go back, try any of these you'd like, and good luck on your practice and quiz me's.